Okay, let's do this problem about hypothesis testing. So um, we have some raw data. That's the way this one starts out. It says the length of time it took a random sample of 32 former smokers to quit smoking permanently are listed. They give us the population standard deviation. For a hypothesis test, we have to have alpha. And we want to know, based on this data, is there enough evidence to reject the claim that the mean time it takes smokers to quit smoking permanently is 14 years? So that's a statement about the population mean. Okay, so we've got a sample and we're going to try to figure out if we have reason to believe or not this claim that the mean time or average time it takes the whole population of smokers, among those, the mean time is 14 years or not to quit smoking. Okay, so I have made some notes about this problem I wanted to go through. So we have information about the population and we have some information about the sample. We start there and make sure we can differentiate between the two. So as far as the population goes, we know the population standard deviation. That was given. You don't have to figure that out. It's just given. And mu here, it's a Greek letter mu, is the population mean. Now we don't know that, but we're trying to figure out by way of the sample if we can make some claim about that, okay? The hypothesis test will investigate the claim about the population mean. As far as the sample goes, we know the sample size. They said we have data from 32 former smokers about how long it took them to quit smoking. And this X bar right here, that's the sample mean, okay? Now that wasn't given, but we have the raw data here and I can open it in StatCrunch because in order for me to make an inference about the population mean, I have to know something about the sample mean, okay? It's all based on that. So here's the sample, right? This is the length of time it took for these former smokers to quit smoking. And this person, did I read that right? 20 years to quit. Oh, okay. So yeah, this person, it took 20 years, 6 months to quit smoking. That's what it says though. And so I'll go to calculators, or sorry, summary stats, columns, select my column, VAR1, and then I'll go ahead and I'll calculate the sample size, whoops, and the sample mean, okay? Because it said 32, but just let me make sure. It said the sample was of 32 smokers, former smokers. Okay, so all right, sure enough, the sample size is 32, that's N, and the mean is 16.135. Okay, now that's what I have here. Sample size 32, sample mean 16.1375. All right, now the hypothesis test procedure will go like this. Now, for what I'm about to show you, I'm following the same steps that I have in the video I posted about this procedure. Okay, so like step one, as you see it here, is the same as step one would have been in the video I posted already. Okay, so, but as I had made that video and the steps I outlined for you, the first step was to state your hypotheses. Okay, now, this here in red, like that was the question that was posed to us about the population mean. And it was worded like this: is the mean time to quit smoking in the entire population of smokers, is it 14 years? Okay, so that would make the null hypothesis be mu equals 14. And then what's the complement of that? What's true if this isn't true? The alternate hypothesis, u is not equal to 14. Okay, so we're going to decide which one of these that sample leads us to believe. That's what the hypothesis test is. Is the mean time to quit smoking 14 years or not? Okay, now, and I guess you could like intuitively think that, see the sample mean? It's not 14, but is it different enough than 14 to believe that the population mean isn't 14? Okay, because the sample does reflect something about the population. Anyway, So my second step is alpha, that's the level of significance for the test, okay? And that means that if alpha is 0.05, that means that as we make some ultimate conclusion from this hypothesis test that we could be wrong. Statistics does rely on probabilities and chance, but this level of significance says that if we're wrong, it will only be a 5 out of 100 chance that that happens, okay? So it's not real likely that we're going to be wrong once we finish this whole thing up. But it's possible, 5 out of 100 times. All right, now the third step, we need this number called the standardized test statistic, okay? And we take that from the sample mean minus the population mean times the root of the sample size divided by the population standard deviation. Now, didn't I say up here we weren't given the population mean? Yeah, we didn't say. We got the sample size, the sample mean, population standard deviation. We don't have the population mean. We don't know what it is. We're trying to make some statement about it and judge whether it's true or not, okay? But we always get, mu, the population mean, as it is right here in this formula. We always get it from the null hypothesis. So if it says here, if the null hypothesis says mu is 14, that means in this formula, it's going to be 14. If this was a different problem, it said, suppose the claim was, is mu less than or equal to 14? Okay, well, embedded in that statement is mu is equal to 14. So we always get it from the null hypothesis. So but x bar minus mu times root n over sigma, and we calculate that with a basic calculator, and we'll get 2.1592. Okay. Next step is to calculate this thing called the p-value. All right. Now, what that is in the case of a two-tailed test, okay, which this is a two-tailed test, is we find the area in the tail of the standard normal curve to the right of this number right here. Okay, and then we double it in a two-tailed test. So see, I got 2.1592. Let's go over to StatCrunch. So open my calculator for my standard normal like this. And I want to find out what is the area in the curve that is to the right of 2.1592. Okay, and there it is. That's the tail right there. And it gives me, well, the area there is 0.015417. Okay, there's that number. Okay, you see where I got that? It's to the right of this on the standard normal. I double it in the case of a two-tailed test. Okay, if the null hypothesis says mu equals this number, it's always a two-tailed test. If it says mu is less than or equal to or greater than or equal to, it's a one-tailed test. So this is two-tailed. There's my number from my standard normal calculation. Multiplied times 2, I get 0.0308. Now, it's from this number right here that we make our conclusion about whether it's true or not that the mean time to quit smoking is 14 years. All right. So if the rules of hypothesis testing, as I had described them in another video, were that if the p-value, that means this number here, is less than alpha, which that's this number here, then you reject the null hypothesis. And in our case, it is like p-value 0.03, alpha is 0.05. Okay, so yes, so that's the case. You reject the null hypothesis. But what's that mean? Well, I'm rejecting, this claim right here. This. I'm saying that's not true. I don't believe that's true based on this sample. And if I'm wrong, it's with only like a 5 out of 100 chance that I'm wrong. Okay, so yeah, we're rejecting that. We're saying, in other words, the mean time to quit smoking is not 14 years. Okay. Anyway, so that's the run through of the whole hypothesis test procedure with probably a little bit more discussion about what we know about the population and sample and what we do with those numbers throughout the test.